Welcome back. So, I got some questions. When's gonna be a VXwheel 5? While I do have some ideas, it's not planned right now because I'm so happy with my VXwheel 4, still riding it to this day. So I'm riding this design for about 2 years now, and it has just for real exceeded my expectations in so many ways. It's still my favorite board, and there is no VXwheel 5 just because I'm so happy with it that there's like almost nothing I want to change on it. I've been through so many events and travel with it. It has gone through a ton of mud and water in the UK, Scotland, in the muddy Belgium, in Denmark. For real, each time I opened it, I was afraid there's gonna be some water, and never. It was never a drop of water inside. That's just beautiful. 100% everything dry. All this mud, everything's clean and dry. Never even sand from Portugal, nothing at all. There is zero dust inside, which is great. So it's still very good, and I'm very happy with how everything turned out. It just outperforms my expectations. I'm even building a new one right here, as you can see. If we look, for example, to the stock XR fender, it is not ideal for this because as it's built, it directs water directly onto the footpad, directly to the gap that is sealed in between the footpad and the box in my case. So all the water that's spinning around goes directly to the edge that is the most exposed and the most fragile for water entry. And again, in the front as well, it's pouring water directly on the footpad, potentially under your grip tape or whatever, even affecting your sensor. So definitely not a great fender design, especially not for a box design that opens right under the footpad. One thing that definitely adds up to my board being very good with waterproofness is also how its fender is designed. There's no gasket here right now because it's a new unfinished board, but once you have the footpad here closing, the most fragile edge is obviously this edge, because all the water is spinning here and you don't want it to enter the controller or the battery box. So what I do as an extra safety above the gasket that's already there, I use this fender design that extends below this edge, meaning once you use a fender, it doesn't shield your feet from getting wet, but it also shields this gap from getting wet as well. So all the water that's spinning around in this fender is directed away from the most critical edge of the design, which is definitely this gap. So I know my fender is pretty complex. This is CNC milled and the rest I make from composites, and it's quite a lot of work and not cheap at all to make. But I definitely suggest you use at least some kind of fender or half fenders or something in a similar design, can be even 3D printed, that will protect this gap from water. Yeah, the gasket's there and it's doing its job, but you're also jumping up and down on the footpad, compressing, decompressing the foam. So check your gaskets regularly, change them if needed. Use some kind of half fenders or fenders if you want extra safety, and you're gonna be all good. So we're not gonna talk about a new board, but we are gonna talk about VXwheel 4 updates. This is pretty much a VXwheel 4.1 at this point, and the only major update is the split pack battery design, because that's all I kinda wanted to add on it. It adds simplicity, it's more user friendly, so I wanted to try it out, and here we have it. In this video I'm gonna explain how to build and wire the new Split Pack BMS battery packs, and with this I think this is now really the ultimate travel board. Extremely user friendly, you cannot connect it wrong anymore, and just the best experience you can get traveling with your board. I experienced a single failure of this board, and that was the motor, so totally not related to the VXwheel design or anything. There's a separate video about it if you want to watch that. So let's focus on the Split Pack BMS. It's based on the Ennoid Master BMS, which is still attached to the same plate. It goes to the same position as it used to go in the normal VXwheel 4. The rails, the frame, everything's the same. What changes are the 3D models of the battery packs and these 3D printed positioning blocks for the battery that go in the frame. So make sure to download the newest files of those if you're printing this. Make sure to download the latest files of the split pack battery cases if you're building it. The wire loom has less wires, we're gonna talk about that, so it's even easier to fit. This is gonna be a limited edition board with hard anodized black rails, and it's gonna probably be for sale soon. We're gonna see about that, but right now let's dive into the small changes. So if you're building this board, this is the video for you, and also for the ones that are just curious how everything's done. And if you want to use the Split Pack BMS slaves in your board, I'm happy to get them to you. Just reach out and you can also use them in different packs and your own custom build as well. So if you're not familiar with it, split packs are made for easy air travel because they're under 100 watt hours and legal to fly. My previous design had all the sense wires from each battery going through the BMS in the back, so it was a ton of wires, a lot of work to assemble, and if wired in a wrong way you could damage the BMS. Now with this system, each pack has its own BMS inside, and everything that you connect are the data SPI cables to the master, so each pack is now individual. And if you don't mess up the main cables, which you shouldn't because there shouldn't be a way to connect it wrong, if you connect the communication wrong, nothing bad's gonna happen. You might just get wrong data and you're gonna fix it. So now it's really user friendly, and I can't wait to be traveling with this system because it's gonna make even my life easier. So what are the updates on the battery packs to get them fit the Master Slave BMS? There are actually more or less two. You should print new files. They are very similar, but they have these slots for the BMS. Some have it here, some have it on top. You will see it on the way. Just don't forget you need to print different types of packs. One very big step forward are those custom-made tabs that are made from 0.2 mm nickel and 0.3 mm copper on top. And these will make your work extremely easier. It is so time consuming to cut the nickel strips. I hated that process, so this is a big improvement. You just put the part in place and you spot weld it and you're good to go. It's very fast now. So until here the process is pretty much the same. You insert the cells, you check the polarization of the battery, and you spot weld this side, you spot weld this side, and now you just make the exit tabs pretty much the same way you did it previously, but just using these tabs. You place the tab where it should be, you mark where do you want to have it bend, you bend it nice 90 degrees, and it should fit perfectly now, as you can see. So this is how easy it is to create tabs right now. Now we're gonna solder the wire on this tab the same way we did it before, but this is so much easier and so much faster. So let's get these packs all welded up. You have the instructions how to do it in my previous videos. With these tabs, the only thing is changed. You need a little bit more of the power on the spot welder, but the K-weld can do it easily, and probably any good spot welder as well. Other tabs are the same. It's actually 6 different ones. And how you spot that you're using the correct one, when these lines are aligned, is the correct one. For example, here they are all aligned. This one would not be the correct one because it would be sitting like this. So you take the one that makes the line aligned. As for the exit ones, you cannot really miss. I made the exit line to be aligned and this one not, but you look at the exit line and this is how it should be. So yeah, once you add the exit tabs, the positive and the negative one, your battery packs should look like this. Take care about the wire lengths, how long it should be here, how long this should be. It's best to look at the pictures of my finished products to determine how long they need to be. They're now pretty much the same as the packs before, without the BMS wiring. So let me finish all of the 6 packs and then I'm gonna show you how to install the BMS. Alright, I'm back quite a few weeks later, but it doesn't matter. We need to cover the BMS split pack system. That is actually the biggest difference in the VXwheel 4. It is compatible with the Ennoid's X-Lite Master. That's the whole purpose. If you have my kit, you got this plate that has all the different holes that fits all the Ennoid BMS units from 1 to 4 and the Master. There's even a newer type of Master. I think it's even smaller, but you don't need that. This one is totally fine. You should mount it with some gap filler between the fats and the aluminum plate, so we get some cooling, and that's mostly it. You screw it. I use plastic screws and normal nuts and plastic washers, and that's pretty much it. The wiring of this is all described on Ennoid's webpage. Pretty much this connector goes to the slaves and it goes to the first pack input, and then you go output to input, and so on till the end of the chain. That's all that you need for wiring the packs. While on this one you will connect CAN high, CAN low, ground and 5 volts to your VESC controller for enabling it. Obviously the battery and the charger goes here. So what we need to cover is the slaves. These slaves are designed specifically to fit the VXwheel 4 packs. It is not the same design as Ennoid used, but it is very close to it. I was testing his design and ran into some issues about reliability when it comes to wiring and stuff. It works in ideal conditions, but I experienced issues as soon as some IME interference was involved from either the VESC controller or the motor or the cabling. Anyway, it's just not robust enough from what I learned. So this design includes way more filtering with this component and some capacitors. We don't need to dive into details, you just need to know it is not the same. It is way more filtered and it should be way more reliable. From what I've tested so far, I had great success and no failures with this design. All the PCBs are the same, but the components are not placed the same. So in packs 1, 2, 3, 4 and 6, you will see these green components are fuses. They are placed here, 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 here and here. These are 5 fuses for 5 wires that goes to the batteries. It's very small, but it's also written here with the numbers. And on pack 5 only, the fuses needs to be all in line here on top. 1, 2, 3, 4 and 5 fuses. It doesn't really matter, I will place the fuses for you if you get this from me. You just have to understand why this is made in this way, not to make any mistakes. These are the pads for the wires that goes to the batteries. It's way easier if I show you like this. This is pack number 1. As you can see, we can take the BMS number 1. Make sure to clean this slot after 3D printing it, so the BMS slides right here. Don't press it all the way in right now. We still need to solder the wires. So leave it sticking out approximately like this. So now you will understand why these fuses are placed in different ways. This pack has negative on this side and positive on this side, meaning you will connect this pad to the first negative of the cells here and then go to the second, third, fourth and fifth one goes to the main positive. So no wire will be crossing at any point. You just know that the first one goes to the first terminal, second one to the second one, that is actually on the other side. Similar to the previous specs, you will run the cable through these holes. Not this one, the screw goes here, so these 2 holes are free. And so on until the end. And this is how it's gonna be done to packs number 2, 3 and 4. They all have a slot like this. Maybe let's just get the first 4 packs that are done exactly the same as this one done, and then we can talk about the 5th and the 6th one. Use some quality wires and let's get right into it. Make sure you do not touch with the soldering iron any pads of the fuses or anywhere. They're all different potentials, so really make sure to only touch the required pad. We solder the first wire here, like this, and as said, it goes to the main negative here. We'll put it here on the edge. Now, this is copper, it's highly conductive, and it can be problematic to solder because it sucks heat very fast, and you also need to solder the wire fast. You don't want to get a lot of heat transferred to the battery. So for this, it's good to use a powerful soldering iron and to do the process fast. So you introduce enough heat on the spot, but you don't let the heat go and heat up the whole battery. So either use a soldering iron on a warmer setting or use a larger one and do your work pretty fast. I'm going to show you both ways. Just do it like this. The solder did spread out evenly on the copper, meaning it's sticking good and it's not a cold solder joint. And then you add the wire, solder it like this, and it's done. It is actually way easier to do it here on the side when there is less copper and you need less heat to do it. Don't do it in the middle. This is going to be extremely tricky. Do it somewhere on the side. We have the first wire done. Let's switch to the second one. And don't forget, this is main negative. The second one goes through the hole on the other side to the PCB. Then we'll need approximately this much of it. Get it through this hole. Leave just enough wire here so the PCB can be pulled out a little bit to see what's going on. So just like this, not more. And once you're on this side, we can do it right here. Make sure not to touch any cells with the metal tools and get the wire in place. And the second one is done. Third one goes from here to here or here, doesn't matter. Just make sure to leave these two spots free for the screws. We can do this one with a larger 80-watt soldering iron just so you see the difference, but the other one was good enough. And we are good to go. Once you add the third wire, the red light on the BMS will lead up for a short while probably, and that's alright. Fourth wire here, fifth wire, I make it red so you clearly see it's positive here on the last one, and that's it. You can see I added some Kapton tape here so that these wires won't touch other terminals, but if you use high quality isolation like these ones, you shouldn't have any issues with that. Don't leave more cables left than this. It's enough. Now we're gonna slide this BMS in place. Must go all the way to this edge. It must align here, and it must not be sticking out here. Once that is done, you press the wires slightly down so they don't make any mess. You can add some small pieces of tape if you want them extra secured. It's up to you, just make it nice. And make sure these two holes are free for the screws. Here's actually some Kapton tape, let's get that away. So the screw will go here, the screw will go here, these two holes must be free, same with this one and same with this one. I also suggest, once you're sure that's it, to add some silicone here to cover this and to fix the wire a little bit more, so you will not, over time, stressing this contact, you will not get this damaged. Silicone's done here and here. Real cover, I'm making these packs double color just because why not. These are M3 screws. You should make the threads for them before. This one's done, very nice. And now the top cover. It's so much easier to close. With the previous packs we had all these sense wires coming out on one side, and it was quite bulky and big and quite difficult to close this pack properly. You needed some practice to do it nice, but now The cables don't need to be thick, they should not cross each other, meaning they take very little space, and you just cover it, add the screws, and it should be smooth. There you have it, pack 1 is closed, nice, smooth, everything as it should be, nice label. As you can see, I also isolated this during the process because you really don't want it touching anything unnecessary. Now, packs 2, 3 and 4, same process, just a small little difference. The BMS sits on the opposite side, meaning you have 3 terminals here and 2 terminals here. Once again, negative on the left side, positive on the right side, exactly the same process. This is the first negative, this is positive. The only difference is this first negative is here and not here, meaning the first wire goes through the hole here, second wire here, third wire here, fourth wire here, fifth main positive through the hole here. And as you probably noticed, we need to pass 3 wires on the other side. So we're gonna use this hole, and one of those 2, whichever you want, just not the central ones. Let me get that done, and I think you will get the point right away. Pack number 2, wire number 1, going through here, done. Second wire here, done. Third wire through here, done. Fourth wire here, fifth wire, red one positive on this side here. That's it, we close it up, same as the other one. Wires in place, do not cross them or make a mess, and that's it. Most importantly, if you've done it correctly, the pack will not be even warm, no heat difference at all. It must be cool. If it's warm, you've done it wrong, too slow. Covers, as always, marked second one, second pack, and don't forget the cases are obviously different, so make sure to print the correct files for the Split Pack BMS. As you can see, I used these 2 holes and this one, so no cable crosses anything. Pack number 3, same story as pack number 2. You can see cables on this side, negative here, positive here, BMS here. Absolutely the same as pack number 2. Pack number 4, absolutely the same. I need to do it this way. Absolutely the same as pack number 1. Cables on the same side as the BMS, negative on this side, positive on this side. 2 terminals here, 3 terminals here. So let me do those 2, because they're exactly the same, and we're gonna move to 5 and 6 that are a little bit specific. Just to mention, what are the temp pads? These are temperature sensor pads, but they're optional ones. There is a temperature sensor already on the PCB, and if you add another one here, it will actually be wrong. So if you would want to use this external possibility of the temperature sensor, you would need to remove the original one that is already on the board. So don't do this. I just want to let you know that's the option, and if you would want to use the external temperature sensor soldered here, hit me up and I'm going to let you know which component here you need to remove for this to be enabled. But just don't, you don't need it. You will get temperature of each pack from the PCB, and that is very good. You don't need anything better. This one is even easier to do than the first to fourth. It's just a little bit more tricky because it's easy to make a mistake. So first of all, always when there is the VXwheel logo, this is on the top. The sticker is on the bottom. Absolutely don't forget, you need to take the BMS that is marked number 5 and has fuses here. And why so? On packs number 5 and packs number 6, the BMS won't be sliding in the pack like this, but it's going to be sitting here on top. This BMS is actually going to sit here, and for that to kind of work out, we will use a plastic washer M3 on this hole. That's just to cover the gap because of this copper that's about 0.5 millimeter thick. We're gonna use Kapton tape. It must cover all of the copper on this top side, and it must not cover the copper on this bottom side. I'm gonna cut the excess Kapton away. We won't use these two holes, they can stay covered, but we will use this. You can put another layer of Kapton on the back side of the BMS. The back side is non-conductive, but there are still holes from the PCB manufacturing that can get some exposure. So yeah, cover this, make a hole here in the tape, get the BMS aligned like this, and we're gonna use a temporary plastic screw to set the BMS in place. Now, one thing that you can do wrong is put the BMS like this. Don't do that. Always top side with the logo aligned with input and output from the BMS. Now to understand why this BMS is different. If you have done everything correctly, you should see the reason immediately. The positive is now on the left side and the negative is now on the right side. So because we don't want any wires here to cross each other, we have switched the logic of the PCB with the different placements of the fuses. So now you can put negative here, second wire through the hole other side, third wire here, fourth wire to the hole on the other side, and at the end fifth positive wire just here to here. That is why this BMS is soldered with the fuses differently. The rest is the same. Let's do it and let's see how it works. There we go, wire number 1. The wires can be way shorter on this side. Second wire, this terminal, isolated this a little bit through the hole on this side. Negative from this side, don't forget, don't mess it up please. Third cell, very short wire. The LED will blink now when we connect it, that is normal, and then it will shut off. That's it. As you can see, I'm doing it all with this 60 watt soldering iron. It's totally enough. Just put it on a higher temperature and do it fast. It's gonna be alright. We have fourth wire left going through on the other side and the red one here, and that's it. Alright, pack number 5 is soldered up, very short wires. Let's close the back first. This is closed. To close the top one, we need to remove this temporary screw that was here just to hold the PCB in place while we are soldering it. And the cover looks like this. And it covers everything like this. Should fit perfectly. And we use the same screws. Almost forgot about the silicone here. And now let's close it up the same way. Same screws. Beautiful. Make sure the plastic washer is still here, because otherwise you would be bending the PCB while tightening the cover. So cover like this from the side, input and output connectors out. It's same thing, just not sitting here but sitting here, because we have place for it in the front box to be here, and we have place on top in the rear box. That's the only difference. And big success, with one single PCB I have managed to do connections, positive on the left, positive on the right, and mounting it sideways or on the top. Everything with a single PCB design. This cuts cost quite significantly, because these PCBs are not extremely cheap to make. And if I would have like 6 different designs, that would be a nightmare. So I'm happy this is behind us. And now let's finish with the 6-pack. So once again, logo here, BMS like here. Don't forget about the Kapton first. And as you can see, we have negative on the left and positive on the right, meaning the PCB has fuses here and is the same as number 1, 2, 3, and 4, and it's gonna be mounted as number 5, but it's connected as 1 to 4. I hope you get it. We always start with the negative wire first, so 6-pack again from the left and till the right positive. Let's do it. There you have it. 6-pack is soldered exactly like the other ones. We'll take this screw away, we'll close it up, and that is it. Make sure the wire is not in the way, or anything else is not in the way of where the screw goes. Right here, take the cover number 6. Okay, pack number 6 is done. All packs are done. That's all you have to know about installing BMS units in VXwheel 4.1 packs. I'm going to show you a few extra things that have changed and are updated, but they're minor things. What has changed into the wiring? Because of the split pack BMS, you need less cables going front to back to the BMS for the voltage sense cables. So I used to have 3 6-wire looms like this. One was for the BMS data and 2 were for the front packs cell voltage cables. So we are dumping 2 such cables out of this wire loom, and we are adding 1 twisted pair shielded cable for SPI communication for the BMS. So in general, that's all is changing. You will have 2 of these less and 1 like this more, and the whole thickness of the wire loom is gonna be smaller, so it's easier to pass through the cable glands, easier to pass through the motor blocks. All in all, it should be just better. I won't go through all the details about wiring because mostly it's just the same. So from this 6-wire loom, we're taking 4 for the BMS communication with the controller. So CAN bus, 5 volts ground. The other 2 wires, I'm splitting them into 2, go to the rear lights. So that's all 6 of those used. This one is SPI communication pack to pack, meaning you need 1 cable like this, JST from here, from the BMS to the first pack's input, that is Pico-Lock connectors, and from this one you just go pack number 1 input out to pack number 2, and then when you're at pack number 4, which is here, you take this SPI cable going to the front to pack number 5 input, and from output you go to pack number 6 input. The output on the 6th pack stays empty. This is how you wire the split pack BMS. It's really easy. Just be sure to handle these connectors nicely. They're small. You need to press on the edges before you pull them out. Don't just pull them recklessly because you're gonna damage everything. That's kinda it. The rest is wired the same. I'm not supplying these cables with the kit. That's what you should get yourselves. If you don't want to manually crimp them, there are pre-made cables like this available from Molex under these part numbers. However, they are not wired correctly. You need to swap the 2 wires on one side only, and you need to twist them. All the SPI communication needs to be twisted like this, and once again, because this PCB design is wired so that pin 1 goes to pin 1 always, and I don't know why the cables that are pre-made and you can buy go pin 1 to pin 2, which is not really a standard thing, but that's what we can get. And then I just take one of the cable and cut it and solder it to the end of this thing, and from one I make this one. I just install the GST on it. Okay, another thing just to mention, hypercores and all generation superflux motors all had these blocks that you could take this cable cover away, and because this frame is a one-piece frame, once you assemble it the rails don't go apart. This is why we need these kind of blocks to slide the motor onto this cable, and some new generation motors don't have this cover plate for the cable, but they have it already attached to it in one piece, so that you would need to like take the rail off, put the motor in and take the rail on. And there are plenty of one-wheel frames right now available that do need this cable cover. Razor rails and things like that, and of course my VXwheel all need this cable cover. on this side, not on the motor cable side. There it doesn't matter because the cable is on the motor anyway. So I'm just gonna briefly show you what I do to fix this issue, because some new generation motor blocks just don't have this option. What I do, I cut the cover away right here, so this line is now smooth with the gap. Then I drill 2 holes, make taps, M4 usually, and just use another plate to cover it up. I just have pictures, I didn't film when I was doing it, but it's a quick and easy fix. You just need a tap drill and a cover plate that I will provide with the kit, not this one. Just some extra work because the motor suppliers are changing designs and there's nothing I can do about that. Also about controller compatibility, I used to run these boards at Tronic 250R. It's obsolete now, so we need to change. Some of you got this bottom plate with holes that fit Tronic. If you're getting one right now, I have a few that have holes for the MK8 from Ennoid, but honestly the controllers are changing faster than I can adapt. If you're using a controller that doesn't fit, just cover the holes you don't need and drill other ones, make taps. It's easy, you know. The only limitation is this size for the controller. With the new split pack, the packs are a few millimeters thicker here in the front, so I write down how wide the controllers can be, and you can use any controller that fits into this gap between the 2 packs. It's just a few millimeters less space than for the Tronic 250R right now, and I think it wouldn't fit anymore with the split pack design. The MK8 fits nicely, there's even space for the Pro version here, not a problem. And if you're using other controllers, just figure it out, shouldn't be much of a problem. There's still a little bit work to be done on this board, but there's one such already riding. The BMS is working as it should. So I hope you enjoyed all of these tutorials. If you have any additional questions, hit me up on Discord or anywhere else, and I'm gonna do my best to help you out. I hope you enjoy the VXwheel products, and I hope we're gonna ride again soon.